It's Monday, I guess the 13th of October, which is Thanksgiving Day today here in Canada. Today we're going to talk about MGB and relays. And if you can see here, I've been working on installing a couple relays, actually 5 relays, in this 1974 MGB GT. You can see just to the left there of the circuit or the fuse box that I've welded a panel with the 2 holes in it that is going to accommodate the 2 relays. One that's going to control the ignition system, and the other is going to control all the rear lights, the parking lights, the turn signals, and so on. I've completed installing 3 relays in the front to control the high beams, low beams, and the horn circuits. And this is pretty much done. I've just got to wrap up the wires there. It's kind of fussy work, but I enjoy doing that kind of stuff. And this one should be has been tested out. And an interesting thing is that this vehicle, the parking lights, so when you flip the light switch on by half before you turn the headlights on, none of the parking lights would be working. As soon as I put this relay in, all of a sudden those lights began to work, and I think that it's as a result of the amount of current draw through that switch, and it just couldn't pass the current. So that switch is likely dirty. We'll likely have to pull that out and clean it up with some contact cleaner. Anyways, I'm going to show you some circuits that we're going to do with bypassing the switches, and that's the whole objective of putting relays in, is to bypass that high current through the lights and the ignition system horn by passing it through the current, passing that current through the switches, which they tend to fail, and although for a 40-year-old car, I guess things do fail. This is a 1974 MGB GT. I've been working on this now for, it's coming up on 3 years. Just putzing along, and it's doing some body work on it. I did the sills. Put some new sills on it, and new dog leg. So I'm just got to do some more welding on there, and all this stuff I've been learning as I go, and reading MG Experience, which is just a wealth of information. The engine's been rebuilt. Local shop here did that for me, and so it's up and running finally, and so now I'm just doing some electrical work, and let's get back to relays. Oh, by the way, I have another car over there underneath the blanket there, and that is a 1974 MGB Roadster. So convertible and a hardtop. So I've got a pair of cars here, and this one I've had since I've been about 20 years old. Not much to see other than the blanket. So it's kind of got me interested in this model of vehicle, this hardtop. I haven't even taken it out other than a drive around the small bay that we have here. So fenders hanging on the wall over there, they need to be done. I actually bought 2 GTs at the same time, both 1974s. One was a rust bucket, and it is now in all those boxes up there. So I stripped down all the parts out of it, and they're all cataloged in those boxes there. So all of those parts are common between both the Roadster and the GT. But anyways, let's get on to relays. So in order to supply power for the relays, I've put this auxiliary panel in here. I picked this up at Princess Auto. It was about 14 bucks or something, but it's got 4 circuits and it's fused. And if you see the feed wire at the bottom with the nut on it, you'll see that that comes back from the starter. So I got up underneath the car, took the rubber cover off the starter, and I connected that directly to the starter, which is in turn connected to the battery. So I've got full battery power up there. I think that's a a 12 gauge brown wire that I've put up there. And then I've got two circuits that are going to be used in this particular project, where I have one that's already connected there with that red wire that's wrapping around the wiring harness. That goes up the front, and that's going to handle the lights and the horn. And then once I put the relay on the auxiliary plate there, I'm going to have the ignition and the rear lights that are going to be controlled by it. So I took this metal plate here. I chopped that up and made a plate that fits there, and I did some spot welds on the top, and I put a couple nuts on the back and welded them on so that I can just screw onto them without having to fiddle around with nuts holding on to the relays themselves. And I just tack welded it on. I spot welded it on the top, and then I tack welded it on the side, and then I painted it up. And you'll notice this engine bay is pretty clean. It's been stripped down and been totally redone. Again, fussy work, which I tend to enjoy. And new radiator. Unfortunately, the radiator that came with the car was unknown, and as soon as we pressurized, it started springing leaks all over. So that was changed out. Some new hoses, new oil pressure or oil cooler hoses, and that alternator is probably toast. I rebuilt that, but the indicator light is on. So that's just another project I have to work on to try and figure out what that is. This is a blown up diagram that I have. I downloaded it from Advanced AutoWire, and it's for this vehicle here. It's a 7374 US market MGB from Haynes, and this is freely available on the web at Advanced AutoWire. I took this and I had it blown up, it actually comes as a PDF file, and it was able to be blown up and plotted out with a plotter. So where I'm going to insert the relays is at this point here, and the relay will effectively fit inside this circuit here. And as you can see, these two are strapped together, so feeding both number 2 and number 4 off the fuse panel. So if you follow the wires along, we're going to come down to the front parking and marker lights are going to be fed by that side. So one is the left side and one is the right side, and you'll see up here this is just the other side. In addition, we're going to go all the way down here, and we're going to service the tail, rear markers, and license plate lamps, both left and right. So if you have some funny electrical problems where one side of your car the lights don't seem to be working, good possibility is the connections at those at that fuse box on 2 and 4. I had that problem, and it really puzzled me until I studied the schematics and realized that that each section is fed by a different connector on the fuse box. So I jiggled it around, and boof, all the lights came back on. So that was kind of a quick fix, but again, MG experience. Do a little bit of searching on there, and poof, you got the problem fixed. So again, we're going to put a relay in this circuit here, and we're also going to put a relay in this circuit here, and this is the white wire, and we're coming up and we're going to the ignition switch. The ignition switch is feeding here, so I'm going to put a relay in here, which also sets out to the ignition coil as well. So I'm going to put a relay right in here, and feed the that voltage here to seatbelt module, the sequencer as it's called. We're going to go to the reverse lights and the reverse light switch, the gearbox switch, again to the seatbelt module, and to the brake switch and to the brake lights. So that's an important area that we want to protect this brake switch. So and And you can see here that what I've done is I've run a tap through those two nuts that are welded on the back there. I caught a little piece of on the welding, I caught a little piece of the nut on there, so when the screw went in it was a little tight. So plus I painted it, so I just cleared off the paint, and so now those screws will go in nice and slick. So before I install this relay, I'm going to do a little bit of preventative maintenance on this fuse box. As you can see by the back of the fuse box, I just took two screws out, and out it came. The connections there are pretty corroded and basically oxidized. So I'm going to take a small wire brush, wire wheel, and on a Dremel tool, and I'm just going to clean those up and try and clean out whatever I can, gunk that's in the connectors themselves. And I've got a battery shut-off switch on this vehicle, so I've disconnected the battery because we've got some brown wires there, and as we all know, brown wires are direct to the battery, so unfused. So if you touch the ground or anything, you're going to have some sparks and possibly some burnt wires. So I'm going to clean that up. Okay, we're back, and here's the relays that we're installing today. This is just a standard automotive relay, 12 volts, 30 amps, and that's the wiring schematic of it. And a more exploded view is here. We're going to provide our plus 12 volts from our auxiliary panel that we put in, and when this relay gets pulled in, it's going to provide it to the source where we want to move it on to the rest of the circuits that are using it. The existing wires, so for example the white wire that's coming off the ignition, it's going to come off here, and here is going to go direct to ground. So once the ignition switch is turned on, it's going to energize this coil, which is going to pull this relay down, and in turn it's going to provide that 12 volts to pin number 87, which is going to connect to the fuse box on pin number 5. So again, it's going to go here to pin 5. And I kind of misled you a little bit earlier on as to what the objective here is. And while the wires here are providing 12 volts from the ignition switch, I guess I got to move the camera before I start pointing at stuff. So by putting a relay in this circuit, the ignition switch is still going to pull that relay here, but all of this circuit here is going to be fed through the plus 12 volts of the contacts for the relay, which is going to give, it's up to 30 amps that it can pass. So all the current that is going to be fed on these circuits is no longer going to go through the ignition switch, but rather through the relay. So the current draw on that ignition switch is going to drop dramatically, and hopefully that'll save the switch and heat and all the other good stuff that comes with high current flow. So in the red wire here, the red-green, where we're going to do the same thing, is this red-green is fed here from the headlight switch, and this circuit here goes right back to the battery. So this is unfused brown wire, and it goes right into your dashboard. So pulling all the current for the lights, the lights and the marker lights and so on, there's a lot of current running through this circuit, and by putting the relay in this junction, we're going to take that current away from that headlight switch, and we're going to put it through the relay from our auxiliary panel. That's going to reduce the wear and tear on that switch dramatically, and the heat. And the end result is that switch should last longer, and it should result in brighter lights. And again, it's not the headlights rather, but the tail lights and the marker lights and the reverse lights. So when I had a video of earlier in the video, I had a picture of the fuse box, and actually both these wires were connected to the 1-2 connector. So I actually just realized that while I was cleaning up that circuit, or cleaning up the fuse box, that, geez, I had these things hooked up wrong, but they'll work either way because they are strapped here. But again, this one feeds the left side, sorry, the right side, so this feeds the right side of the circuits. This feeds the left side, and again, feeds the front parking marker lights, tail, rear marker, license plate lamps, and so the net result of adding this relay is I should get a brighter lights than what I have today, because of the amount of current that is no longer required to flow through that headlight switch. Again, this is just a standard automotive relay, a single pole, single throw, and there's a bit of an updated or exploded diagram of it. So we've got the fuse box cleaned up. I'm quite pleased with that. All the connections actually are copper as opposed to just brown shitty with dust. Whoops. And so there's the two relays installed on the that auxiliary panel. So this red wire here is going to feed up into this section. So this is going to be the output of the 12 volts from that auxiliary panel. So once that relay is kicked in, this is going to energize, and it's going to provide my voltage to my rear and front marker, tail lamps, and so on. This wire here is going to get disconnected, and it's going to be connected here to the relay, which is the input, or which is going to energize that coil, and this is our ground wire. So once we turn on that light switch, this is going to energize. It's going to energize this circuit here, and through here it's going to pull that coil in, and then it's going to give me that 12 volts right here on the that high current circuit. And the white, the ignition. So the ignition is connected here. This white wire is going to come off, and it's going to connect on this side. And the other end of the white wire is here, and it's going to connect up where the white wire is today. And that is going to feed all those other lights. And again, that's going to save your ignition circuit. The amount of current flowing through the ignition circuit is going to be a lot less as a result of this. So the next thing to do is just hook it all up, and we'll take it from there. And just to finish up here, that auxiliary panel that I talked about earlier right here is got a nice little plastic cover on it, so if I drop any screws or anything in there, I won't short everything out. The two relays are in, and they're working fine. Well, I turned the battery switch back on and turned the lights on. So we have lights now. The fenders aren't on the car, so the lights are just kind of sitting on the front of the car here. So I've got my marker lights on, and also the headlights on. I had no sparks or anything when I flipped on the switch. So those relays are kicking in, and if we go to the back of the car, we'll see that we've got lights on, marker lights and taillight lamp. One of the bulbs is burnt out, and so this was a successful adventure of doing relays on an MGB GT. And to correct all my previous errors, we inserted a relay at this point right here, and what that does is this voltage here comes from the headlight switch, and that middle connector there, that middle conductor, actually provides the voltage for the marker lights and the parking lights, as well as the license plate lights. So I interrupted this circuit, and I put the relay in here, And so what it has done is it's taken out all that current flow that is going to those lights I mentioned is no longer going through that switch. The current that's going through that switch is going through the coil of the relay to ground, and very, very, very small current draw there. So the load on that switch has gone down dramatically. Again, on the output of these two connectors here are strapped together, so these are common to that red wire. And here we've got I believe the left side of the marker lights, and the front parking light and marker lights, and the tail lights, and the rear marker lights, and the license plate lamp. And on this side here is the right indicators. And in addition, we also put a relay in this circuit here, and this is the white wire, and it's coming off the ignition switch, and it's actually strapped to the voltage that goes to the ignition coil. We're not switching this, we're using this to switch the relay. So we disconnect this wire and we connect it to the coil of the relay and then to ground, and at that point it's going to energize that relay, and it's going to provide me with voltage at this pin here, and it's going to feed all these green wires. And so we're going to go over to the brake switch, and we're going to do the brake lights. We're going to go down here and we're going to pick up the reverse lights, and we're also going here. And an important aspect that I didn't mention in earlier parts of the video, we're going to feed the rear window defogger, which obviously isn't in the convertible car but is in this GT, and that's a very high current draw component there. And we're also going to pick off and provide voltage to the tach, and then through the gauge voltage stabilizer to the temperature gauges and sender gauges. In addition, we're going to come down and we're going to feed that sequencer circuit. It's kind of just a pain in the butt, actually. It just, whenever you open anything, it buzzes at you, seat belts and so on. And the other result of this, and I did this relay on the other vehicle, and the other result of this is that we're going to see improved lighting on the dashboard too, because there's not going to be as much current flowing through that switch, and that switch actually feeds through the dimmer switch and then onto the various lights on the dashboard. So instead of feeding all of those lights through that switch, we're only going to be feeding those marker lights, and so that the net result is that those are going to be brighter as well. Or that's what I found with the other vehicle. So in addition to those other circuits, you'll see that the rear window defogger also loops back down through the hazard switch and provides power to the turn signal flashers. So there's my my column switch for turn signals, and so we're going to actually feed all the turn signal indicators as well through this relay, and so all that current, there's a lot of indicators that are going to be fed through this relay that we've put in. So we're going to get a fairly good result from this. That was just from those two relays that we put in. So now we have the other three relays that I showed you at the start on the front of the vehicle, and what we're going to feed there is our light circuit. So basically those relays are inserted in at this position here at the front of the car. So this now is going to feed the coil on the relay and to ground, and in turn we're going to provide that switched power to the low beams, and this one other relay will provide it to the high beams. and we're going to take all of that current out of that switch as well. So now we've got this switch is controlling just a couple relays, which is very low power draw, considerably lower power draw. The other circuit that we did was the horn circuit, and that third relay in the front is going to come in from the horn, and this is kind of a goofy configuration here on this diagram, and it's actually it took me a while to figure out what the heck I was doing here, but basically the relay is put in this circuit here, and once you push the horn button, it draws this to ground. So what we're doing here is, instead of providing power here, we're actually providing a path to ground here on the relay. So the relay gets pulled in, or the relay actually gets energized when this horn button is pushed. So I've got 12 volts on this side, I've got the coil, and then the horn button brings the circuit to ground, which in turn pulls the relay and provides the path to ground on the horns, and this scoots up to the top here and is fed in off of this fuse here. So it's I think I saw about a possibility of 6 or 8 amps coming out of this horn. That the horn is one of the highest current draws in the whole car. So that one's taken care of now too. I hope you enjoyed this video, and if you have any questions or anything, this is my first video and on YouTube, and it's just done on my iPhone, so I've been putzing around with it. I hope you enjoy it. If you have any questions or comments, I'd love to hear them.